Welcome back. Today we're talking about applications of quadratics. Let's go ahead and take a look at example A. So here in example A, it says this rectangular garden needs to cover 513 square feet. The length is 8 feet more than the width. Find the dimensions using the quadratic formula. And we've got the quadratic formula down there, and it wants us to know that we need to reject any answers that are impossible because length and width can't be negative numbers, so therefore we can't have negative lengths and they are impossible. So any of those answers we can rule out. So it says the rectangle is going to cover 513 square feet. So we know we're going to be talking about area. So our area formula is going to be area equals length times width. And now we're going to substitute in the pieces of information that we know. So we know the garden is 513 feet to start with. We know our length is going to be 8 feet more than our width. So that's going to be 8 plus W, because we don't know W. And then we're going to do times width, which we don't know either, so that's going to be W. Here we go. So now that we've got our equation set up, we're going to go ahead and set it up into a quadratic. So we're going to do 8 times W, which is going to be 8W, and W times W is going to be W squared. So then we're going to end up with 513 is going to be equal to W squared plus 8W. So we're almost at a quadratic. We now need to make sure that it's equal to 0. So to do that, we're going to go ahead and move that 513 to the other side. So we're going to subtract 513 from this side. We're going to subtract 513 from this side. When we do that, we end up with W squared plus 8W minus 513 equals 0. So now that we have done that, we can go ahead and plug in our values into our quadratic formula. So we're first going to calculate the discriminant. So we know that that's the part underneath the parenthesis, underneath the square root. So we're going to do b squared minus 4ac. In this case, our b squared is going to be our 8. So we're going to have under the square root symbol, we're going to have 8 squared minus 4 times 1 times negative 513, because that is our c. We go ahead and type that into our Desmos calculator. You can do it by hand if you want, but I highly recommend the Desmos calculator. When you do that, you're going to get the square root of 2,116. So this indicates that it's a positive, so I know that I'm going to have 2 answers here to our quadratic formula, but again, we want only the solutions that are possible, so we're going to end up ignoring the negative solution. So continuing forward, the square root of 2,116 is going to be 46. So now we're going to put in the rest of our quadratic formula, so negative 8 plus 46, because again, remember, we're ignoring the negative solution that we're going to end up with, and 2 times a, and a is 1, so that's going to be 2. So now we're going to do negative 8 plus 46, so negative 8 plus 46 divided by 2. Again, you can type this all in your Desmos calculator. That would be my recommendation, but you can, of course, do it by hand. And if you do this, you're going to end up with getting a width that is going to be 19. So our width is 19, which is great because that's one of our answers, but we also need the length. So we're going to go ahead and plug that in, because remember, the width is 8 feet, or the length is 8 feet more than the width, so 19 plus 8. So 19 plus 8 is going to be our length, and 19 plus 8 is going to be 27, so our length is 27. So our length is 27, and our width is 19. We found the answer to our problem. Now let's go ahead and take a look at the next one. So here in example B, it says Alex throws the ball straight into the air. He wants to know how high the ball goes and how long it takes it to land on the ground. The ball leaves Alex's hand 4 feet above the ground and is thrown 25 feet per second upward. How long will it take it to hit the ground? And we're using this equation, 0 equals negative 16t squared plus 25t plus 4. And we're going to graph to find our answers. So first we're going to get out the important information that we want here. So we're going to know that we want to know how long the ball, or how high the ball goes, and how long it takes it to land. So we want 2 important pieces of information. So now we're going to take out our Desmos calculator and plug that one in. Now we have to use x instead of t because that's how our Desmos calculator works, but we're going to plug in our equation and then see our important points here. So we've got 2 important points on our graph. The first one says 0.78125 and 13.76563. That is the apex of our graph. So that is how high the ball goes, because it doesn't go any higher than that, and it's going to come back down. Now we need to make sure that we're reading the correct one, and we want to be recording the y value, because that's going to tell us how high it's going to go. So we're going to round that to 13.77, so 13.77, and we'll call that feet because we know it's going up in the air by feet. That's how high the ball is going to go. The next question wants to know how long it's going to take us, and so that we can see down here, we're going to have it when it hits 0, because when it hits 0, we know it hits the ground. So the ball is back down on the ground, and we're going to record the x value in this case, and that's 1.7, and we're going to round that to 1 seconds, because that's how long it takes it to get the ground. Now, it's very important that you remember which one you're looking for and that you label your answer, because this is a word problem and it needs a word answer. Now let's take a look at the last example. So here in example C, it says a golf ball is chipped into the air from a small hill. The ball travels with an upward velocity of 50 feet per second. Use the equation 0 equals negative 16t plus 50t plus 10. So again, we're going to take out our graph and our Decimus calculator. So here we've got our Decimus calculator, and we want to know the maximum height of the ball, and the starting height of the ball. So the maximum height of the ball in this particular case is, where did it go up? Again, at their apex. And our apex here, after 1.5625 seconds, it got to 49 feet and a little bit of a rounding here. So we're going to say that 49.1 feet is how high that it reached. Now it also wants to know the starting height of the ball. And we'll notice the starting height of the ball is our y-intercept, right, where it crossed the y-axis. But we'll also notice that that's our c value in our equation. So our c value and our y-axis are the same points, and that's important information to remember. So where did it start? It started 10 feet in the air, and that's where we're going to go. Or it's 10 feet off the ground in this high hill that we're talking about. And that is our answer to that question. That brings us to the end of this question. It also brings us to this set of notes. If you like this video, go ahead and say thumbs up. If you love this video, go ahead and say sub. And we will catch you in the next one.